Welcome to Forge College. Let's explore the essential blueprints and settings for your smart contract workspace. In our last session on parallel transaction processing, we talked about how blockchains handle heavy traffic, like a massive multi-lane highway. But before those cars can even hit the road, they have to be built. And for smart contracts, that means setting up a proper factory. A lot of developers jump straight into writing raw code without mapping out their workspace first. What happens next? Files get lost, compiler versions clash, and nothing works when it's time to actually build the project. That's where the hardhat config file steps in. Whether you use JavaScript or TypeScript, this single file acts as the factory floor manager. It takes all that chaos and organizes it into a smooth, predictable assembly line. Understanding this manager's clipboard before you write a single line of logic means you won't be guessing later. You guarantee your code compiles perfectly, exactly the way you intend, every single time. Let's walk onto the factory floor and look at the main assembly lines. In your config file, this is the compiler section. When you write a Solidity file, you usually slap a sticker at the top called a pragma statement. Think of it as a routing label on your raw materials that says, "Hey, please use version 0.8.17 tools to build this." The factory manager reads that sticker, checks the compilers list in your config, and automatically routes your code down the belt to the right machine. But what if you have an older piece of code? Say you're maintaining an old token contract written years ago. If you send that frayed, dusty blueprint down the brand new modern assembly line, the machines will reject it and the line stops. This is why your manager has a feature called overrides. An override is a custom, cordoned-off fabrication station. You tell the config file the exact name of your old file, and the manager diverts that specific file to an older, dedicated machine, like version 0.6.12. By setting explicit overrides, you get precise control. Your brand new contracts and your legacy code can happily coexist in the exact same project without causing any fires on the factory floor. Now, let's talk about how the robotic workers actually build your code. You have an efficiency dial called the optimizer, and specifically a setting called runs. Tuning the optimizer forces a choice between two financial costs: the upfront fee to deploy your contract to the network and the long-term gas costs for people to actually use it. Turning the dial down to a low number, like 200, tells the factory to build the contract quickly without overthinking it. As you can see on the cost chart here, the result is a contract that is cheaper for you to deploy initially, but users pay more gas every time they interact with it. On the flip side, if you crank that dial up to 1,000, the robots spend extra time meticulously polishing the code. Watch the chart reverse. Your deployment cost shoots up, but the per-call cost shrinks to a sliver. It becomes highly aerodynamic, saving your users gas on every single transaction, forever. Locking in these optimizer settings in your config file means your code builds exactly the same way every time you run it. That predictability is essential when you're auditing your code or benchmarking your gas costs. Finally, let's look at the factory logistics. Your config file has a path setting, which acts as a map showing the manager where all the physical materials live. First, you have the sources folder. This is your loading dock, where you drop off your raw, uncompiled Solidity code. After processing, the finished products are stored in. This includes the machine-ready instructions called bytecode and a translation manual called the ABI that tells other apps how to talk to your contract. Think of it as your final shipping warehouse. By letting the config file manage these paths, you never have to wander around your computer guessing where your finished smart contracts ended up after a build. When you open your hardhat config file, it might look like a wall of syntax at first glance. But really, it's just a highly logical set of factory instructions keeping your workspace organized. Just remember the 3 rules. Always make sure your config has a compiler that matches your code sticker, use explicit overrides to keep legacy files safe, and lock in your optimizer settings so your gas costs stay predictable. In our next lesson in the Ethereum Dev Stacks and Frameworks track, you'll put this into practice. You'll write a basic Solidity contract. Place it on the loading dock in your sources folder, and watch your carefully configured factory produce your first artifact. This video was created by Forge College. To learn more about smart contract compilation and explore other Web3 topics, come visit us at forge.college. See you in the next lesson.